Here in Module 7.1, Class Notes, Example 7, we now turn our attention to compound interest. Let's read the problem and see that we can recognize this word problem as a compound interest problem. If you invested $5,000 for 10 years at 9% interest compounded quarterly, how much money would you have? The key word there is that the interest is compounded. So we need our compound interest formula. That is, like we saw in example 1, compound interest is future value equals present value times 1 plus the nominal interest rate raised to the n number of compoundings power. Let's parse out the information that we're given here and see if you invested $5,000, that's your starting amount, your present value. For 10 years, that's your years, 10. At 9% interest, that's your interest per year, IY. Let's call that, as the book does, let's be consistent with the textbook here and call that IY for interest per year, 0.09. And then the interest is compounded quarterly. So we'll say CY, the compoundings per year. If it's compounded quarterly, then that's 4 times per year, each quarter, 4 times per year. How much money would you have? Now, looking at the formula, FV is what we're trying to find. How much money would you have? What's your future value going to be? FV is equal to PV. We know our present value is 5,000 times 1 plus I, the nominal interest rate, which is the interest rate per compounding, not per year, but the interest rate per compounding, which we calculate, and this formula is in the textbook as well. We compute, or compulate is a new word. Anyway, I equals IY over CY. If we're earning 9% per year at 4 compoundings per year, then we cut that into 4 pieces and have 0.0225 or 2.25% that we are earning in interest every compounding, every quarter. And then in our formula, our N, our capital N, our number of compoundings, if we are compounding 4 times per year for a total of 10 years, then over 10 years, 4 times every year for 10 years, our number of compoundings will be, as stated in the textbook, compoundings per year times the number of years, 4 times 10, that's 40 times that we're compounding interest. So this 0.0225% that we're compounding, well, every time we compound, then how many times are we compounding? A total of 40. We use that in our compound interest formula then, and we have 5,000 times 1 plus 0.0225 raised to the 40th power. Working this out according to order of operations, I'll plug 1.0225 to the 40th power in my calculator and get approximately 2.435189 times 5,000. It's 12,175.94. And so, after 10 years, at this rate, we would have approximately $12,175.94.